Hello guys, we want to start our 17th lecture. In this lecture, we want to talk about solving Volterra integral equation using Laplace transform. So first we have to know what Volterra integral equation is. This equation is a type of equation in which an unknown function appears under the integral sign. For example, here you see 1 Volterra integral equation. Ft is equal to gt plus integral from 0 to t f tau ht minus tau d tau. So in this equation, ht and gt are known, and we have to find ft. So in fact, ft is unknown and should be found. So ft is unknown and should be found. We can easily find ft using Laplace transform. So here we have one example. In this example, we're going to see how we can solve Volterra equation using Laplace transform. So in this example, you want to solve a given integral equation. Ft is equal to 4 times e to the power of minus t plus sine t minus 2, the integral from 0 to t f tau cosine t minus tau d tau. In order to solve this equation and find ft, we have to take Laplace transform from both sides of the equation. So if I take Laplace transform from left hand side of the equation, so we have Laplace transform of ft. And if I take Laplace transform from right hand side of the equation, so we have 4 times Laplace transform of e to the power of minus t plus Laplace transform of sine t minus 2 times Laplace transform of integral from 0 to t f tau cosine t minus tau d tau. So Laplace transform of ft is equal to f capital S. We have to find it. It's equal to Laplace transform of e to the power of minus t. So we know that we have 4 here, 4 over s plus 1 plus Laplace transform of sine t, it's 1 over s squared plus 1 minus 2 times. So here you can see we have a convolution integral. You know, in the Laplace transform of convolution integral is Laplace transform of first function, which is ft, times Laplace transform of second function, which is cosine t. So you have Laplace transform of convolution in the formula sheet as a result. So fs, it's equal to 4 over s plus 1 plus 1 over s squared plus 1 minus 2 Laplace transform of ft is f capital S. Laplace transform of cosine t is s over s squared plus 1. So we have to find fs. I just bring fs times s over s squared plus 1 to the left hand side of the equation and then factor fs. So here we have fs. We have 1 plus 2s over s squared plus 1. It's equal to, so what's left? So here we have 4 over s plus 1 plus 1 over s squared plus 1. So I just simplify left hand side of equation. If we have s squared plus 1 in denominator, so we have 1 plus 2s over s squared plus 1. As a result, we have s squared plus 1 plus 2s times fs. It's equal to 4 over s plus 1 plus 1 over s squared plus 1. So we can simplify more. So in numerator, we have s squared plus 2s plus 1. So it's s plus 1 s squared over s squared plus 1 times fs. It's equal to 4 over s plus 1 plus 1 over s squared plus 1. As a result, fs it's equal to 4 times s squared plus 1 over s squared plus, sorry, 4, yes, over s plus 1 squared times s plus 1 plus s squared plus 1 over s squared plus 1 times s plus 1 s squared. So we could find fs. I can simplify fs. Fs is equal to 4 times s squared plus 1 over s plus 1 to the power of 3 plus, so I can cancel out this guy and this guy. No, sorry. Yes, I can cancel these two. So what is left is 1 over s plus 1 s squared. Now, if you want to find ft, you have to find Laplace inverse of fs. So in order to find Laplace inverse of fs, we need to use partial fraction decomposition. First, I find partial fraction decomposition of 4 times s squared plus 1 over s plus 1 to power of 3. So if you look at the partial fraction table, so we have a over s plus 1 plus b over s plus 1 squared plus c over s plus 1 cube. If I add them together, so the common denominator is s plus 1 to power of 3. We have a times s plus 1 squared plus b times s plus 1 plus c. As a result, left hand side of equation we have 4 times s squared plus 1. It's equal to right hand side of equation, so we have a times s plus 1 squared, so it's s squared plus 2s plus 1 plus b times s plus 1 plus c. So now I look at coefficient of s squared in right hand side and left hand side of equation. So coefficient of s squared. In left hand side of equation we have 4s squared, so we have 4. In right hand side of equation we have a times s squared, so a is equal to 4. If I look at coefficient of s in left hand side of equation and right hand side of equation. In left hand side of equation we don't have s, as a result coefficient is equal to 0. In right hand side of equation, so we have 2as, so we have 2a plus bs plus b. So we already know that a is equal to 4. As a result, b is equal to minus 8. Now we look at coefficient of s to the power of 0, the constant values. In left hand side of equation we have 4. In right hand side of equation we have a times 1, so it's a, plus b times 1, so it's b, plus c. We already have a and b, so we can easily find c. c is equal to a is 4, 4 minus b is 4 minus 8, so it's going to be minus 4. As a result, c should be equal to 8. So we could find a, b, and c. So for s squared plus 1 over s plus 1 to power of 3, it's equal to a, which is 4 over s plus 1, minus 8 over s plus 1 squared, plus 8 over s plus 1 cube. So now we have partial fraction terms. You want to find Laplace inverse of fs. Fs is 4 times s squared plus 1 over s plus 1 cube plus 1 over s plus 1 squared. So let me write fs again. So fs, it's equal to 4 over s squared plus 1 over s plus 1 to power of 3 plus 1 over s plus 1 squared. Squared. Now I write partial fraction terms of first fraction, so it's 4 over s plus 1 minus 8 over s plus 1 squared plus 8 over s plus 1 to power of 3 is partial fraction of the first fraction, and we have plus 1 over s plus 1 squared. So we can simplify again. Fs is equal to 4 over s plus 1 minus 8 over s plus 1 squared. Here we have plus 1, so it's going to be minus 7 s plus 1 squared plus 8 over s plus 1 cube. As a result, ft, which is Laplace inverse of f capital S, it's equal to. So Laplace inverse of 4 over s plus 1 is 4, based on the first translation theorem, e to the power of minus t minus 7. Laplace transform of 1 over s plus 1 squared, it's t e to the power of minus t plus Laplace inverse of we have 8, Laplace inverse of 1 over s plus 1 cube, so it's t squared divided by 2, so e to the power of minus t. So we could find ft in Volterra integral equation.